Today we will discuss about this microsystem for micro robot, basically focusing upon the manipulation related applications or manipulation related mechanisms. So, ideally in the last module we have discussed most on the micro engines, on the micro pumps, the different configurations of micro pumps. The case of micro engines we have discussed about this piezo based systems, thermal based systems, then fluid based systems. So, we also had some discussion about this magnetic helical based systems, etc. Now, the focus of this particular module will be like towards micro manipulation, so that this micro manipulation can be effectively used for the movement of this micro robots, or to handle a certain amount of functionalities or products for a functional related application. So, ideally it is a kind of manipulating the structure, so towards micro robotic systems. So, in this particular module, so we will be discussing about some of the key aspects where manipulation has been taken up a front seat to ride the micro robots for an effective applications. So, some of the manipulation methodologies ideally includes the acoustic manipulation, the atomic force microscope, which is used as a kind of a micro and nano robot, how it is used. So, we will discuss in detail. Then we will also discuss about the micro manipulation in particle assembly. So, we will also have a detailed discussion about the 3D micro nano fiber pulley and how it is integrated as a nano tool carrier. So, we will also discuss some of the case studies relevant to this particular system. Now, as a first part, so as far as these micro manipulations are concerned, so like the first fundamental of micro manipulation is in the form of a particle assembly. So, ideally these micro manipulation, it utilizes the domain of the particle assembly to precisely arrange the microscopic particle to form a specific pattern or structure. So, either it might be a kind of a periodic structure, or it might be a kind of a mechanism where we can have a kind of an arrangement, and through that we can deploy a kind of a particular we can solve a particular problems. Like for instance, there is a case study where the main focus of this case study is to remove the fat content inside a. So, there is so we have the a hose kind of arrangement. So, in this hose, so there is a kind of a particle which is being collected over here. So, we may need to remove this particle. So, one option is we can align the micro manipulated particle in terms of a grinding wheel, so that this grinding wheel can be appropriately actuated to grind these kind of particulates which are being collected in the tube. So, these manipulation, it utilizes a kind of different kind of controlling micro robots which manipulate the position of the particle using various physical interactions. So, some of the physical interaction ideally include a magnetic field, a light, an acoustic, and a mechanical interaction. Now, let us see some of the different strategies which are being deployed for such kind of manipulation. So, as far as in this manipulation strategies are concerned, so some of the key domains which are being effectively used are the magnetic field, the mechanical grippers, the optical field, and the acoustic field. Now, in this micro manipulation in part assembly, in the particle assembly, so when we try to consider the magnetic field, there are two different technologies which are being effectively used. One is called as a magnetic field induced assembly. So, and the other one is called as a magnetic assembly. So, in the case of a magnetic field induced assembly, so some of the key features which basically involves the directional control, the nanoscale of the magnetic field, real time tuning, high assemble efficiency, a long range translation order. Similarly, in the case of magnetic assemblies are concerned, so there is a kind of a non-contact system which exhibits, and then it has a kind of a reconfigurable formation which exhibits. It has a jamming free assembly, and it is bit robust. On an application perspective point of view, as far as these nanoparticles are concerned, it has a nanoparticle assembly, and it has a one dimensional anode, a two dimensional monolayer, and it has a 3-dimensional chiral assembly. It also has a kind of a polymer film and a kind of a mesoscale structure which exhibits over here. As far as applications are concerned, it has a magnetic levitation and a structural construction which are being effectively used for this or effectively considered for this particular system. Now, if we closely observe the other magnetic based systems are concerned. So, there is a kind of a magnetic assembly which exhibits, basically it is a kind of a jamming free assembly, it has a good error recovery and it has a predictable orientation. So, ideally when we try to apply a magnetic field appropriately, we can have a predictable orientation. Technology perspective point of view, it has a magnetic micro robots. So, when we try to look into the feature, it has a low toxicity and it has a remote actuation and control. It has a kind of a reconfigurable locomotion modes. It has a tunable structure with a morphological and a chemical feature. It has a high maneuverability and a long term stability. As far as application perspective point of view, it has a structural construction, it has a quite a good amount of cell transportation and drug delivery and a kind of a bacterial inactivation which exists in this particular applications. Now, if we closely observe the overall advantage of this system, so in this advantage it has a kind of a biocompatible power supply. Like when we try to look into the advantages, the one of the key advantage of this magnetic actuation is it has a biocompatible power supply. A relatively reliable operability, it has a strong penetration and long action time. So, these are some of the advantages which such kind of magnetic systems exhibits. However, when we try to look into the limitation perspective point of view, fabrication is considered to be one of the key challenge for such kind of systems. Second thing is, like if you have a span of micro robots which are actuated with magnetic field, it is quite easy to handle. However, individually controlling it, that is selective control, will be highly difficult in such kind of systems. So, this is one aspect which we may need to consider when we try to select a magnetic field. Then we have a kind of a mechanical gripper. So, as far as these mechanical gripper perspective point of view, some of the key features ideally involves the kind of a closed loop system, a position with offset compensations, and then there is a kind of a hybrid force with position and a visual servo. It also has a kind of a feedback control which exhibits. Then there is a kind of a availability of multiple grippers and end effectors which exhibits over here. As far as application perspective point of view, it has a kind of a 2D and a 3D pattern construction which are considered to be some of the key applications of this particular system. Now, optical field based manipulation is also considered to be one of the key aspect of this particular micro manipulation. So, in this concern, if we observe, like we have the kind of a different manipulation strategies which exhibits. So, in the case of optical field, we have the light, and when we try to look into the features perspective point of view, there is going to be a stable optical matter arrays which exhibits, and it is kind of hierarchically self organized particles, and the particles are gathered in an aqueous medium. Application perspective point of view, it has an electrodynamic interaction, a photochemical micromotor, and a plasmonic antenna which exhibits. With reference to technology and optical tweezer perspective point of view, we have a multicellular organism based capture. It has an automated recalibration, it is highly efficient, and it has a closed loop control. and with reference to application perspective point of view, we have a structure construction, a patterning, a cell recognition, isolation assembly and transportations are considered to be some of the key applications of this particular systems. Now, like another important aspect with reference to a micro manipulation perspective point of view is the acoustic field. So, in the case of an acoustic field, so we have a kind of an ultrasound driven system. It is a kind of a like it is highly used for kind of underwater application perspective point of view. So, these when we try to look into the applications kind of thing, so these applications are kind of like manipulation of living cell and organisms, and it is a kind of a ultrasound driven gripper, and it is highly used for targeted drug delivery. Okay. So, like we will be discussing more about this acoustic based system in detail. So, before going into it, so let us discuss some of the other type of actuation mechanism which exhibits and which are being effectively participating in the in this overall micro system related application, especially on micro manipulation perspective point of view. So, in this concern, let us make a small comparison, like apart from magnetic system, we also have the biological actuation. So, some of the key aspect of this biological actuations are, it has a kind of a biocompatible power supply, and like it has a combination of actuation and sensing capabilities. It is highly useful for naturally suitable for psychological fluids, physiological fluids, it is relatively efficient in such kind of fluids. Okay. However, with reference to limitation perspective point of view, so it is more prone to a specific environment. Which will be fueling the micro robots. Next, when we try to look into the chemical actuation perspective point of view, it has a fast actuation speed, so it uses a kind of a biocompatible fuel like urea, glucose, H2O, more on self portic propulsion. Some of the limitation perspective point of view, it has a high risk in vivo cross reactivity, insufficient propulsion accuracy, it has a short action time, and it lacks instantaneous feedback. So, these are some of the key limitations with reference to chemical actuation perspective point of view. Let us discuss about the acoustic perspective point of view when we discuss more in detail with reference to acoustic system. So, let us see some of the different configurations of these acoustic systems. So, acoustic system, acoustic based manipulation is concerned, as the name suggests that, like ideally it is because of a kind of a bubble formation. So, these bubble formations, like it has an impact towards manipulating the either the product or the micro robot based on the different needs. So, when we try to look into the overall configurations, so there are different generation or different source of this bubble formation. So, one of the bubble formation, either it can be through chemical reactions, like either it might be kind of a reaction through a chemical in a particular environment. In certain cases, we can also use a kind of an optothermal effect, through an optothermal effect. So, when we try to focus a kind of a beam in a particular medium where bubbles can be generated, or sometime it might through direct acquisition. And in certain cases, we can also use a kind of an acoustic oscillation in generating certain amounts of bubbles. And then there is a kind of a technology which is called as electrowetting dielectric technology, which is being effectively used for a kind of a for generating such kind of bubbles. And then like there is a kind of a generator and a kind of a through a catalytic reaction also it is possible, which also has an impact with reference to chemical reaction. And then we have a kind of an acoustic oscillations, like through certain amount of mechanically stable acoustic oscillators, bubbles can be generated, which can be effectively used for a certain actuation. Now, when we try to look into some of the key domains of such kind of bubble generation in robotics, so like one is with reference to a kind of a bubble based micro robots, where the micro robot system itself will have a kind of a bubble based actuation. So, by appropriately giving a kind of, by appropriately generating the micro bubbles, there will be a kind of a propulsion mechanism which exhibits. Second is through a kind of a generation and control. So, like we can generate a bubble and then appropriately we can orient the micro robot in that particular orientation, so that the movement can be appropriately displaced and it can be effectively controlled. Second, next important aspect is the kind of a bubble micro manipulator. So, the main function of this bubble micro manipulator is something like this, like for example, if I want to, if there is a kind of a domain which exhibits over here and there is a kind of a debris which is available. So, if I want to manipulate this debris, so I can generate a continuous bubbles, and through this bubbles there will be a kind of a like a dispersion which happens, or pressure which tries to come out of it. Through this pressure the debris will try to move, or the debris will try to manipulate. Okay. Now, so these are some of the operation which exhibits for a kind of a micro manipulation in a particular environment. Okay. The most important aspects with reference to this bubble based system is a kind of a bubble propulsion is considered to be effectively used for different such kind of acoustic based system. So, when we try to look into the bubble propulsion, so the operation is ideally through the kind of a microfluidic operation. So, in the case of a kind of a acoustic based micromotor, So, which this is efficiently used for like microsurgery. Next, a kind of a sharp edge systems are there, like acoustic based sharp edge system. Which is highly used for a kind of a targeted drug delivery. And in addition to this, there are other two modes are there. So, one mode takes care of the particle separation and the other modes take care of the self assembly. So, in a simple term, if this is going to be a kind of an acoustic micro robot, so we have the bubble propulsion, an in situ micromotor, and a sharp edge system. So, this will come under the microfluidic domain. This will come under the micro surgery domain, and this will come under the targeted drug delivery domain. Okay. Now, let us see some of the different configurations of these micro robot as well as with reference to acoustic manipulated perspective point of view, especially focusing on the bubble propulsion. So, when we closely observe the working principle of the system, so the vibration is excited by the acoustic field, which reaches to a kind of a resonant frequency of the bubble. So, these bubble vibrates outward and inward, and the liquid in the device will be discharged and sucked based on the kind of a pressure difference or with reference to the bubble manipulation or the bubble propulsion. When we try to closely observe the flow pattern perspective point of view, so the flow pattern generates a source of net momentum for driving the force to push the entire device forward. So, the acoustic waves can provide a powerful propulsion forces and acoustically excites the bubble can produce a high streaming forces. So, like if we try to look into the overall construction of this system, so this is a kind of a bubble column which is available, this is going to be a propulsion and this is going to be a generated flow. So, through a generated flow, so where here this is going to be a bubble column. So, this bubbles are generated by different modes like we have discussed about the photothermal effect, catalytic base, etc. So, these are the different source through which bubbles will be generated, and through the generation there is going to be a flow which will try to come out of it, and then there is kind of a forward propulsion which exhibits over here. So, the speed of this particular system can go in the range of 45 mm per second, and the overall propulsion force exerted will be in the order of 6 micro nanometers. Now, let us see some of the case studies where there is a kind of an acoustic actuated micro robot bubble propulsion system as there. If we closely observe in this, this is called as armored micro bubble system. So, in this armored micro bubble system, we have a transducer in place, there is a kind of a water medium and the PDMS structure which is available. In order to have a kind of an actuator, so there is a kind of a salt water and a bead kind of arrangement which exhibits over here. In this particular case, the vibration of the bubble interface under the ultrasonic force resulting in a strong acoustic streaming jet of passive particles suspended in the fluid and are seen flowing from the back and sides of the fixed armored micro bubble towards their opening, before being pushed forward away from the AMB. So, as far as in this particular case, the fluid jet is directed away from the kind of this armored microbubble, and basically this armored microbubble provides the basis for a propulsion mechanism, and it gives the order of magnitude of the velocity for a free swimming device. So, ideally this is a kind of arrangement which exhibits over here. So, this is a kind of an insert image. So, where there are water and the particle which is available, and then by giving a kind of a, so when there is a transducer is there, these transducer will excite and it will create a kind of a propulsion mechanism. Ideally bubbles will be generated. So, these bubbles will try to align these beads in a particular fashion, and because of the movement of the beads, so we can expect a kind of a propulsion mechanism, and this the overall propulsion mechanism will have an impact on the magnitude and the velocity. So, ideally these transducers will act as a source for generating the or for orienting these bubbles in a particular direction, which will take care of the magnitude and velocity for an appropriate propulsion. So, this kind of configuration is called as a kind of an armored microbubble configuration. So, this is a kind of a bubble based micro manipulation. So, as far as in this bubble based micro manipulation is concerned, we have a kind of an electrowetting on the dielectric. So, here if we closely observe in this particular system, there is going to be a piezoelectric actuator. Over this piezoelectric actuator, we have a electrowetting electrodes, and then there is a dielectric layer which is available. Then we have a kind of a micro object where there are bubbles are there which is kept, and then there is a hydrophobic layer and a liquid medium which is available. There is a kind of a top ITO glass plate which is being placed. Now, what is happening is, this is a kind of an ideal state. So, in this ideal state, the piezoelectric actuator is off, and now when we try to switch on the piezoelectric actuator, there is going to be an oscillation which exhibits, which will try to have a control over the micro object which is available over here. So, ideally the micro object will take up a kind of a micro manipulation stage, and then there is a kind of a piezoelectric actuator which ons, so that like on and off will be highly helpful to generate a kind of a bubble which will get generated, and these will be help for an appropriate manipulation. So, ideally, so this electrowetting on dielectric, so the principle behind this particular system is, even though a bubble is generated, the mechanism of proper manipulation is decided by this particular mode, where we have a kind of an electrowetting on the dielectric system. The contact angle between the droplet and the dielectric layer is changed. It can be used to manipulate the generation, transportation, mixing and splitting up of droplets. So, when an electric voltage V is applied between the aqueous sessile droplet and the electrode, the droplets spontaneously spread out on the dielectric surface, and the contact angle is modulated by the applied voltage which is exhibited over here. So, the overall like magnitude and the overall frequency and the overall displacement is completely taken care by this electrowetting behavior, as well as the electric voltage applied on this piezoelectric structures. Now, this is a kind of a bubble based propulsion mechanism. So, in this bubble based propulsion mechanism, we have two different mechanisms. One is called as a dispersion based mechanism, and the other one is called as an aggregation based mechanism. So, aggregation based mechanism, it is towards manipulating to a particular region. Dispersion based mechanism is something like to disperse the particle in a kind of a cloud, in a kind of a environment. So, for in both these cases, there is a need to go for a kind of a source to generate a bubble. So, one is through a kind of a sonoelectrode, which is basically meant for enabling a kind of a dual swarming mode, which includes a kind of a dispersion and aggregation, which exhibits in this particular system. So, overall in today's lecture, so we had discussed about the different types of micro manipulation which exhibits. So, we had discussed about the different configurations of micro manipulation strategies like magnetic field, mechanical gripper and optical field and acoustic field based system. So, we had individually discussed about different manipulation of particle subassembly, which includes the magnetic field induced assembly, the magnetic assembly, the overall features of magnetic assemblies and magnetic micro robots. So, we had also discussed about these grippers and the overall feature of these grippers. We had also discussed about this application of optical field. So, with reference to this application field, so what are the different features which are employed and the different characteristics, acoustic field, and we had also discussed about this concept called as direct self assembly, which is more meant for certain amount of non-spherical based particles with suitable application. And then there is an ultrasound driven system, which is basically kind of an acoustic field. We have discussed a lot about this acoustic field based system. We also had a discussion about the other type of actuation, ideally kind of a biological actuation or a chemical actuation, the overall advantages which are involved in this biological actuation and the overall aspects which are involved in chemical actuations. We had also discussed some of the limitations related to this actuation. Now, since we had discussed about this acoustic based actuation, let us discuss about the advantages and limitations of this acoustic based actuation. So, in the case of acoustic based actuation, so it has one of the major advantages is it has a kind of a biocompatible power supply. Second important advantage is it has a capability to control a micro robot deep inside the body. The body. And third is with reference to the flexibility perspective point of view, it has a high flexibility, it has low power consumption, and it has a good long time action. With reference to limitation perspective point of view is required, there is a need to have a proper instrumentation for in vivo use. And one of the important key challenge is the material and design requirements especially for micro robotic perspective point of view is relatively strict. So, these are some of the key limitations with reference to an acoustic based system. So, in the next class we will discuss about an AFM, how the overall principles of an AFM, atomic force microscope, how it is effectively used for micro robotic related applications.